We need to prove the following. In order to do that, we will start from the left hand side of a given expression. So on the left hand side, we have tangent of theta plus secant of theta minus 1 divided by tangent of theta minus secant theta plus 1. Now we need to show that this expression is equals to 1 plus sine theta over cosine theta. Let's try to simplify the expression on the right hand side. Now on the right hand side, we have 1 plus sine theta divided by cosine theta, which can be also expressed as 1 over cosine theta plus sine theta over cosine theta, which will be equals to, now 1 over cosine theta, that's secant of theta, because secant is the reciprocal of the cosine function, plus sine over cosine. This ratio is the tangent function, so we have tangent of theta. So we can say that 1 plus sine theta over cosine theta, this is also equivalent to secant theta plus tangent of theta. Now, this is what we need to show, that the left hand side is equivalent to secant theta plus tangent of theta. Then in that sense, we can say that it's equals to 1 plus sine theta over cosine theta. So we will use this particular expression. So what we'll do, we'll use this expression and multiply it to both the numerator and the denominator. Secant theta plus tangent of theta divided by secant theta plus tangent of theta. So this is a trick that we are going to use. So in the numerator, let's not do anything. So we'll simply have tangent of theta plus secant of theta minus 1 whole multiplied to secant of theta plus tangent of theta. But we will compute the denominator. So let's multiply the two expressions in the denominator. So we have tangent of theta times secant of theta. That gives us tangent theta times secant theta. Then we have tangent of theta multiplied to tangent of theta, so that's tangent squared theta, right? Then we have negative secant theta multiplied to secant theta, so that's negative secant squared theta. And we have negative secant theta multiplied to tangent theta, so that gives us negative secant theta times tangent theta. And then finally we have 1 multiplied to secant theta plus tangent theta, so this will be simply positive secant theta plus tangent of theta. Now immediately we can observe that tangent theta times secant theta and negative secant theta times tangent theta cancels out, and we can rewrite our expression as tangent of theta plus secant of theta minus 1 multiplied to secant of theta plus tangent of theta whole divided by, now here we have tangent squared theta minus secant squared theta. We know there is an identity 1 plus tangent squared theta. So this is equivalent to secant squared theta. So this is a standard identity. So from here we can say the tangent squared theta minus secant squared theta, that will be equals to negative 1. So we can combine these two terms and replace it with negative 1. Then we're left with positive secant theta and positive tan theta. So we have positive secant theta and positive tan theta. Now luckily this expression in the denominator is also repeated in the numerator, so they cancel out and leaves us with secant theta plus tangent of theta. And we know that secant theta plus tangent of theta, that's nothing but 1 plus sine theta divided by cosine theta. Now that means we have successfully obtained the right hand side, and we can say that the left hand side of our equation, that's equals to the right hand side, hence proved.